Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little button that says Q&A. Click on that. It'll open a new window. You can type in your question, hit submit, and I'll get to those at the end of the session. If you're joining us on YouTube, just wherever the live chat is on whatever device you're watching us on, just feel free to use that live chat and ask any questions you have there, and we'll get to those at the end of the session as well. So my name is Jason Gabrinas, one of Snap-on's National Diagnostic Technical Trainers. I've been in the training department the last 9 years now or so, and I've been traveling around North America helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple of years as a diagnostic sales rep with Snap-on. So I had about 30 different Snap-on reps I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So over time, just kind of became that default diagnostic guy in the shop. So I always ended up with the drivability problems, the intermittent problems, those weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bag. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So enough about me. Let's talk about our topic at hand. So in this case, it is VVT, operation and testing. So VVT stands for variable valve timing. And most cars, I think nowadays, have some sort of a variable valve timing system, or maybe even a variable valve lift system, which we're also going to talk about, or some vehicles even have both. So we'll talk through a bunch of different functions on these. So as I said, VVT does stand for variable valve timing. And what that does is it advances or retards the cam timing using the cam gears. So there's some actuators which we'll go into using oil, hydraulically controlling the cam phasers, as you might hear them called. And then we have variable valve lift as well. So that changes the lift and duration, depending, of the valves themselves. Use multiple lobes on the cams in order to do that. And then we'll also talk about how BMW does it a little bit different too with their Valvetronic system. So first off, let's go through the variable valve timing components that we're going to discuss. So first and foremost is our cam gear. So it is a toothed gear, going to be driven by a belt or chain, depending on how the vehicle is designed. This is just a generalized picture of one. Some may bigger, a little smaller, some are chain driven, some are belt driven, but by and large, they work on pretty much the same type of principle. The camshaft is connected with a bolt in the center. There's my bolt there. And as I said, it's hydraulically controlled. So if we take a little bit closer look at this, we have that outer sprocket. So that's where the belt or the chain is going to ride on that, as we would be used to on a non-variable valve timing vehicle. And then we have these oil passages inside the cam gear, and that's going to allow oil to flow into these oil chambers that we have all the way around. There's 10 different chambers on this particular gear. Depends on the vehicle. I know Subaru had 3 lobes in there. Some other vehicles, I'm sure, have more. There's also usually a spring in here, too, to keep it set kind of in one direction in case something fails. That way it can still run and still be driven. Just won't be able to advance. Usually it goes to defaults to the retard side from what I've seen. And also we have these vanes in here to separate the two sides of those oil chambers there. So how do we actuate these controllers or these cam gears? So as I said, it is hydraulically controlled. So we need to be able to control the oil. That's where the oil control valve comes in. So usually it's going to be a modulated pulse width modulated signal for open or close, and it's going to slide this spool valve in here. So that slides back and forth. We see there's some springs in here. There are bearings, and there is coils of wire. It also works on that magnetism principle, electromagnetism. We have the connector up over here, and then a return spring down here. So it moves either in or out and controls how the oil flows through these passages in here. And we'll look at that in a little more detail in a minute. Some manufacturers also do it a little bit differently. So in that case, we saw the oil control valve was more of be externally mounted, somewhere usually on the cylinder heads where you find those. Subaru does it a little bit differently. I think a couple other manufacturers do it this way as well. So what they do is, instead of having it external and then it feeds in through the back of the cam gear, it has these little stepper motors on the front of the cam gear. They kind of go in there and ride in the middle. Cam gear kind of turns around the middle of that. They're bolted on the outside. There's a little O-ring that goes there. And this little pintle here pushes in and out. And what that does is it contacts a valve on the interior of the cam gear. And that makes it actuate in and out, and it moves. It's like kind of a spool valve and cam gear all in one. So it's kind of an interesting way to do that. They also do it the other way too. So kind of get either way, just know that it works in pretty much the same idea, the same principle. It's just we're moving the valve a different way depending on how it's set up. Then, of course, we have oil feed lines as well. So you're going to have your hard lines there, usually with a banjo bolt, couple washers to seal it up. And also inside the system, there are usually filters as well. And that can be a source of failure depending on what we're looking at. We'll talk a little bit more about that in a few minutes as well. So now that we know the basic parts, components that we're going to talk about, let's talk about how does it work? How does it work? So we have our operation here. I'm going to show you a little animation going either. So as I said, we have these oil chambers in here, and it uses oil pressure in order to keep it, move it back and forth. And then the spool valve directs. So if I were to do this and have the valve closed with oil pressure already in there, it's going to keep it in a set state wherever it happens to be. It can close the valve and not allow any oil in or out. So this would be my oil source here. This would be the one going to the blue side, and this is the one going to the red side. So it can open, it can close. If it closes it, it can lock it in a certain, say it wanted 5 degrees advanced or something like that. It could do that. Or maybe it just releases all the pressure and it defaults back to that spring-loaded setting. Now, in this example, let's advance the cam here. So we'll move the spool valve forward in this case, and that allows the oil to come in, go in here, and then it increases the pressure on this side of the vanes, which moves it forward. So let's watch that again. So you see how it kind of rotates and moves forward. So the cam is locked in with the bolt, and this is working on the belt or the chain. So really what it does is it's like moving the teeth, a couple teeth in either direction. So it advances and retards the timing. And then it releases the pressure on the other side, and that goes out back into the oil pan. Go the other way. So if we wanted to retard the cam, so we'll go back this way and we'll move the valve the other way. Oil feed's still in the middle, and then it allows the oil to go in, increase the pressure on this side. This stuff comes out, goes back down in the oil pan on the other side. So it is dependent on oil pressure, which will come into play a little bit later in our conversation here as well. So you have to be cognizant of the fact that you need good oil pressure for this to operate. Now let's talk about variable valve lift. So variable valve lift, if you think way back, and I say way back, but it is over 30 years ago now, we had this thing called VTEC, which they still have. It's just a little bit different of an iteration now, but they have this VTEC, which is variable valve lift timing electronic control. And what that does, and it's not just Honda that uses this system now. Honda, I believe, was one of the early originators of this system, but a lot of manufacturers use it. Subaru uses a system like this, tons of them, a lot of different manufacturers. Just off the top of my head, I know I've done a ton of cams on Subaru, so that just kind of sticks out in my mind. But what makes them different than a normal camshaft is you have two different cam profiles in one camshaft. And that was the revolutionary idea behind this as well. What if we could kind of mold two camshafts together or something of that nature, and let's get it to do double duty for us. So we have these low lift cam lobes you see on the outside, and then we have a high lift cam lobe in the middle right there. So that can they could be the same duration, or they can be a different duration. They can be a little bit they can move them a little bit degree wise if they wanted to. It just depends on what the engineers decided they wanted to manufacture in there. But for how it's going to work, it's going to work the same no matter which way they do it. So it's dependent a lot on not just that camshaft, but also on this rocker system in here as well. So it's going to use 3 rockers. It's going to be 2 valves. Many vehicles that use this system use this just on the intake. But I have seen there's some vehicles that use it on the intake and the exhaust to give them extra control. But usually the most common application is going to be intake only. And you see we have the spring, we have a little piston, we have a couple, they call these pistons too, I like to call them like pins, little metal pins. And there's another one there. And then of course we have our 2 rockers there on the outside. And then on the inside, we have our medium or high lift rocker arm. So what happens is we also have an oil control valve as well. Now you see this looks a little bit different than that spool valve we had, but it has the same type of spool valve inside. It just actuates it kind of over here externally, a little bit off to the side, which uses difference in oil pressure. We have the valve here, we have the solenoid there, and then there's also a pressure switch on there as well. On some vehicles, the pressure switch is mounted somewhere else, but you will find that there will be an oil pressure switch in the vehicle. So what happens when it's not operating, when we're just driving down the road normally? These pins, you see how they line up. We've got the pin there, we got the pin there, we got the spring there. These pins, the spaces between them line up, and they're able to move freely from each other. So in this case, the low rise cams, the outer cams, the low lift cams, will ride on those rockers, and the rockers will push down on the pistons like they would normally do without this system. So it just opens and closes, opens and closes. And in this case, the oil pressure is being dumped off. It's not going into the system. There is a shaft that these rockers mount on. Back up here a little bit. So the shaft goes through here, and it has oil passages, and then the oil passages work through the rockers. So when we want the high lift cam under high load, high RPM situations, whenever that happens to be, whenever the PCM deems that it needs to happen, then it will push oil pressure in. You see how the oil goes through the valve, and it goes into the shaft, and then it comes out the oil galley there, and then it pushes the pin over against the return spring. In doing so, it locks these 3 together. So now the valves are forced to follow the profile of the high lift cam in the middle there. So once they're locked together, it lifts up higher. When the oil pressure leaves, it goes back, and then it's able to free float in the middle, and then the exteriors will operate just like they normally would. Now, you can usually hear it too. If you have, back in the day, I used to have a 94 Acura Integra with this in there. And you could always tell, because if you have an open air intake or cold air intake on the vehicle, you'd be able to hear it. Once you get going, it changes the tone of the intake because it's moving a lot more air. So it actually changes the frequency, changes the pitch, and you could hear it when it went on and went off. It was interesting. It was like real early kind of technology for making those little 4 cylinders fast, but man, it worked good, and it still works today. So that's variable valve lift, one way of doing variable valve. The other way, our friends over in Germany, we know how they like to engineer things. So BMW has this system called Valvetronic. And what this does is it is a continuously variable lift profile, not using different lobes on the cams necessarily, but using an eccentric shaft and an electric motor with a worm gear. So the electric motor with the worm gear, when we're just kind of in a normal operation, these can go all the way to 0 lift, by the way. So if they back all the way out, they will not lift those valves. They will not open those valves at all. So here's the camshaft on the right. And then there's that eccentric arm there. And then there's a little return spring. You'll notice the camshaft rides on this roller rocker here. And that rocker will transfer that energy down into the other rocker, the valve rocker itself, where it would push down the valve. And then it just kind of rides on this pin here. When I want to increase the opening of the valve, we turn the motor, screw gear goes. And then as you can see, we've moved the eccentric over, so it pushed it over more. And now it allows a much higher lift on that valve with the same camshaft rotation. So it just moves this eccentric assembly here in or out, kind of rotates it around depending on how much lift it wants. So it's really infinitely variable by bank. So each bank would have an actuator for it, and it affects all the cylinders on that bank. If it's just a straight 6, then it'll just affect it that way. Here's just an animation of how that works. So right now that eccentric is all the way out. Those valves aren't moving. and then it'll move over to the right there, and they open a little bit, and then it moves all the way to the right, and then they open the lock. So you can see the difference in how that eccentric is moving versus how those valves are going to lift. Now, the other thing about the Valvetronic system is it's a lot of moving parts. It's a lot of stuff in there. There's a lot of possible failure points, and they're designed to kind of be all together. So if you replace one part, you really need to replace all the component parts together, because they're supposed to be a match set. So I couldn't just replace this one little eccentric and hope it works. It might work, but it might not. So just take it under advisement. You should replace most of the pieces. But that's just another way of doing it. So let's talk now about problems. What kind of issues could I have in these systems? And I think you might already be thinking of the first one I'm going to talk about, because this is so common out there. These codes, P0011, actually 0012, and then 22, and then 23. So these are intake and exhaust camshaft position sensors. It could be different variations of this description, but it's some sort of a problem with timing. So intake camshaft, bank 1, bank 2. And what is usually probably the most common issue to cause these codes is going to be something with the oil. Customers, as we know, aren't that good with changing their oil and keeping up with their regularly scheduled maintenance and all that good stuff. So oftentimes the oil can get dirty, the oil can't go away, could be leaking, could be consumption. Oil consumption is a big concern with vehicles nowadays too, I think you'll agree. I know my 2011 uses 0W20 because it has to be able to flow through the passages for the variable cam time. And that's the main reason they went to a 020 synthetic. But the other thing with that is it consumes a lot of oil. And there's, according to the manufacturer, and I think this is pretty standard across the board, according to the manufacturer, standard oil consumption should be 1 quart in 1,000 miles is okay. 1 quart in 1,000 miles is okay. 6-quart oil pan, 7,500 mile change interval. So due to that math, if my car is normal and okay with its oil consumption, I have negative 1.5 quarts in there if I go to 7,500 mile oil change interval. So obviously we need to check the oil quite often. But that's just one of those wild things. The manufacturer said, "Oh yeah, that's fine. That's totally normal." So definitely check your oil if you got one of those types of things. And I can tell too. I can tell when my oil's getting a little low, quart or two low, if I don't check it that often, because the variable cam timing will start giving me like little hiccups and bucking and stuff. So I can kind of tell when I'm getting a little low. It's like, oh man, my car's not running very well. I don't have an engine light, so I guess it's probably time to check the oil. Check the oil, top it off, give it an oil change, whatever you need to do at the time. And then, all better at that point. So that's probably the more common issue. I mean, of course, it can be electrical issues and things like that too. But usually it's going to be a lack of maintenance. Remember how I talked about the filter and the banjo bolt? So the filter and the banjo bolt feeds the whole system. And if that filter gets clogged with dirty oil, dirt, metal particles from the engine, like over here. This is one of those spool valves, actually. You can see the bolt hole right there. This is one of those spool valves in and out. So that'd be a drain, that'd be a drain, and that's the oil feed right there. And that is just chock full of metal. That definitely needs to be replaced, but that could cause an issue, and that might set that code. Otherwise, this valve may very well be electrically okay. So if I go to test this, it still might be okay. So it's just always be cognizant that we need to have nice clean oil. It needs to be full. We need to have good oil pressure as well. All right, so let's go live to that point of the oil. I'm going to walk you through a little live case study, so to speak. Live simulated case study. So I'm not hooked up to it. Can't get one in my studio. It's too small. It won't fit, but I can run through it. So we have this 2008 Ford F-150, and the customer complaint is, man, it is driving. It feels like the transmission's ready to fall out of this thing. I don't know why. It's not running well, and just having all sorts of drivability problems. They thought it was a transmission problem. This is from a real world story too. I'm just paraphrasing. So first thing we do is we hook up the scanner, right? We want to scan it and check for codes because it should be some sort of codes in there if it's running like crap. And oh yeah, the engine light was on too. So let's go in here and do a code scan on this. And it's a pre-scan, of course, because we haven't done anything yet. So we just want to see the state of the vehicle. Ignition switch on, engine not running, hit continue. And then it'll go through all my systems. I've already done this once today. That's why it kind of came up fast. There we go. Saves the report. It's going to save it to the tool. Also automatically uploads it to the Snap-on Cloud if you're signed up for that free service as well. Allow you to share that with your customer. But see, we get a P0022 intake camshaft position timing over retarded on bank 2. And this is a 5.4 Triton motor. It's got 2 camshafts in there. So this will be on bank 2. Hit diagnose. This is cycle the ignition. And let's see what we have. So this is Fast Track Intelligent Diagnostics. It's going to bring me in and tell me what do I need to see for this P0022. Are there any TSBs? No TSBs that apply to this on this particular vehicle. Now that saved me time right there. You think about it. I didn't even have to look for TSBs because by looking at this, I know there's no TSBs. So I don't have to worry about going and searching and seeing if I can find any. Over here on the right-hand side, we got our top repairs. And this is going to generally let us know that it's probably going to be the variable valve timing control solenoid because that's a code for intake cam position timing. And that's what controls the intake cam position. Now, it could be other things, but this gives us our top 6. This gives us our top 6 most common things that were done, most common top repairs. Also, it could involve other things that were put on the repair order at the same time as well. This goes over 2.1 billion repair orders. Replace the whole engine, replace the variable valve timing actuator, camshaft position sensor, control solenoid seal, control solenoid itself, and then engine timing cover. So in order to get to some of these pieces, we might have to go open up the timing cover. That gives us a couple of our usual suspects. Next thing down, because I want to read this kind of like a book, top to bottom, left to right. Next one's going to be my smart data. So I go into smart data, and what this does for me is it is going to go through all the PIDs on the vehicle, filter the list, bring back just the PIDs that I need to see for that I'm be concerned about for this, and then it'll also set these flags. Now, don't really pay attention to this data. It's just dummy data. It's demo data. I guess I said data like 5 times there, but it puts these flags on. So if I see a blue flag, that means that PID is being monitored. It's looking for a good max or minimum value. The red ones mean it's gone outside of that good maximum minimum value, whatever that happens to be. So we have a timing advance on this side. We have a timing advance on that side. So I could open these graphs up and see where my problem might be. And see, it was way over there at the beginning. Right? So it's all over the place. Shouldn't really be all over the place at an idle. Now I know it's on the wrong bank too. That's okay. Let's say, like I said, dummy data. But if I saw it kind of actuating like that, going to 0, going all over the place, that could indicate we have a problem. It could be an electrical problem, or it could be a mechanical problem. I also want to make a point here too with this too, because we get a lot of questions about this smart data, right? So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 21 different PIDs on this list. I can't even scroll. There's not enough to fill the whole screen. So that really filtered down my list. How many PIDs did it filter out? So let's go to my custom data list and see. So I got some stuff off the engine data, fault data, also building it off of multiple data lists, by the way. Well, let's see what it picked out of engine data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of all of these PIDs that could possibly show up, because if I'm trying to diagnose something with my cam timing system, I really don't care about my generator. I really don't care about my knock sensor. I don't really care about my master key, right? We don't care about these things when we're trying to do this. Now, I could build this list myself, but how long is that going to take me? It's going to take me quite a while. You probably tune out by the time I got done building that list manually. So that is the wonderful thing about this smart data. And then, of course, it gives you the known good minimum max values that you could do manually. But once again, Why do I want to take my time doing that when this can help me do it faster? All right, so we looked at the data. Maybe there's a problem there. Maybe we saw some problems in the data. And then we can functional test. There aren't any specific functional tests for this particular problem, so we move on. And then we have our guided component tests. So we go in here, and this allows us to test them directly. Now at the top, it's going to filter it down to just the components we care about in this case, which is going to be a cam and crank sensor because it's a timing problem. ECM could be, and then the variable valve timing systems. We know it could be an issue in there. So we go into variable valve timing. It's going to give us components. Now this is a fairly simple system. Doesn't have a lot of stuff going on as far as the electronics. So variable valve timing solenoids are used to control the variable intake cam timing. Solenoids are controlled by the ECM to open and close oil shuttle valves. Shuttle valves direct oil to valve timing units. When the oil pressure overcomes return springs, the cams move to the advanced position. So these are the ones that are default to a retarded cam, and then we add the oil pressure to bring it overcome that spring pressure and go to a more advanced position. Right, and then we have all of our connector views over here and our pin assignments. And it says when valve timing is in retarded mode, the ECM periodically energizes solenoids to provide a spurt of oil into the valve timing units. The ECM sends this lubrication pulse once every 5 minutes. So that's kind of an interesting little thing. So when it's fully retarded, there's no oil in there. To keep everything lubricated, it'll pulse it real quick just to put a little squirt of oil in there every 5 minutes to keep it lubed up. It may be audible at idle with the hood open when that happens too. So don't freak out if you hear a solenoid popping off when it's on with the hood open. So that's just kind of an interesting little tidbit there. And then we can do a DC voltage test, a resistance test, or a signature test on this. Now the voltage test is just going to be, do we have battery power? And is it good? And then the resistance test is going to give me my resistance value. So resistance should be 20 ohms or less. If it exceeds 20 ohms, suspect a faulty solenoid. That's easy enough. And then the signature test is going to show us the control signal when it's turning it on and off. So we should be able to see when it's on, when it's off. We should see a 12-volt spike and then down to 0 volts when it's turning on and off. So like I said, it's a fairly simple system on this particular vehicle, but that'll give us that information. So we can test it, and let's say it tested okay. Could be. Maybe it tested okay, and we might have another problem. So in this case, we have a real fix. So it says code replace variable valve timing control solenoid. So in this case, this one had a bad solenoid. We also have other real fixes in here as well. And we can see a lot of times it is replace cam sensor, idles rough, replace variable valve timing control solenoid. So it also adds codes in there as well, codes and symptoms, which is nice. Control solenoid, cam position sensor, a couple other ones in here. Let's see. Yeah, so most of them are the solenoid, but not all of them. So here we go, replaced engine oil and engine oil filter. So it could be any of those. Let's go into troubleshooter too. So intermittent rough idle and engine noise. How about that one? So check engine light may or may not be on. Possible codes P0012 or 22. Misfire codes for multiple cylinders. Customer may complain of having intermittent rough running at idle. When an event occurs at idle, raising engine RPM may change engine noise and roughness. Vehicle mileage may be as low as 30,000. Recommend driving vehicle while monitoring oil pressure. Lack of normal oil pressure may be an intermittent concern. Usually occurs on a return to idle after reaching normal operating engine temperature. Oil pressure drops to 15 psi or lower when the engine roughness and noise occurs. Raising engine RPM changes the roughness and the engine noise. So when I increase the engine RPM, it increases the oil pressure going to it. So it allows it to work. So you would see possibly excessive crankshaft end play. Correct oil pressure keeps camshaft phasers advanced based on command from PCM. Lack of oil pressure can cause the cam phasers to retard, causing the running problem and setting various codes because the computer wants it advanced to a certain spot and it's not, so it doesn't have enough pressure to do so. So oftentimes checking the oil pressure is a way to do that as well. Verify lack of oil pressure, inspect camshaft caps for excessive scoring. Timing cover and valve covers off, remove oil pressure center, install an adapter and put a pressure sensor in there. We don't necessarily need to do that. But in this case, on this vehicle I'm talking about, what it ended up being was a low pressure situation. They tested the pressure and it was 14 psi. Now spec is a little more than that. Well, what is the spec? Go into my shop key and see what the spec is. It's much higher than that. I don't remember off the top of my head. That's why I'm going in here anyways. But so if we come in here, it's going to pass me. It's going to pass my login in. It's going to pass the vehicle in. And then it is also going to do a search for my code, so P0022. Now I can go through here, and I can get my specs and everything. Real fixes, top repairs, tests, component operation, wiring diagrams, all that good stuff. But right now, I just want to see what standard oil pressure is. So I'm going to go to my common specs over here on the right. And we'll go down a little bit. It's going to be engine. Oh, I think I went past it. Engine mechanical. There we go. And then 5.4, oil pressure, hot at 2,000 RPM. 40 to 75 PSI. So if we only got 14 PSI, that's a problem. That's way, way, way low. They need a minimum of 25 to 28 PSI in order for them to even operate on those cam phasers. So 14 PSI would be way too low. They ended up finding the source of that low oil pressure ended up being a bad camshaft seal. So it wasn't sealing properly, wasn't holding the pressure back. And then it was kind of just leaking back into the system. So all the pressure was being lost that way. So with that, that was an oil pressure problem. So doesn't always have to be an electrical problem with a code, right? Doesn't always have to be an electrical test that we could even do. Because in that situation, I could test those solenoids and they would test fine. If I function them back and forth, they would work fine. They would ohm out correctly. The signature would look fine. Everything would look fine. But they're not working correctly because of that low oil pressure. And sometimes that even brings us back to the, let's think about basics first too, right? Does it have oil in it? Does it have enough oil in it? In this case, it would have had enough oil. It was leaking out pressure. So it could be a whole host of things. I just thought that was kind of an interesting, different. It wasn't necessarily the solenoid, but we can walk through that with that system. All right, so that is our Ford. And I'll give you one more little bonus here tonight. So we'll go into guided component tests here direct, and I'm going to load our BMW demo car because that has both systems. Going to the engine system. So guided component tests, if you're not aware, it's our database of over 5 million component tests on lots of vehicles, right? It's over 5 million tests. So it works all the way back to 1981, covers most of the vehicles we cover in the scanner. And we see we have different components inside this engine. There is also ABS, charging system, and transmission, but we're looking at it. So in this case, we have a couple things. So we have our Vanos solenoid, which is their term for their variable cam timing. So we have these Vanos solenoids in there. The solenoid operates by controlling the amount of engine oil between two chambers in the camshaft adjustment unit. Camshaft adjustment unit. It's fancy. By creating higher pressure in one chamber than the other, the adjustment unit will extend or contract depending on which chamber pressure is greater. So this has the little, that's what they call the little solenoid. The camshaft timing is typically slightly retarded at idle for improved emissions and idle quality. During acceleration, the camshaft is advanced to enhance the efficiency of combustion. Intake camshaft control solenoid is ground controlled by the ECM. It is used to modify intake cam timing by directing oil flow through the Vanos unit to advance the intake camshaft. This will provide an improved torque curve. At idle, the solenoid is de-energized. This maintains a retarded intake camshaft position. Best place to test it is at the ECM. Alternate test location is at the camshaft control solenoid connector itself. The intake and exhaust Vanos solenoid valves are mounted to the front of the cylinder head. The intake solenoid valve is on the top. The exhaust solenoid valve is the one at the bottom. May be difficult to access the solenoid, so we're going to tell you go test it back at the computer, which makes sense. Some tech notes as well. If oil temperature is extremely hot, like above 212, the DME deactivates camshaft solenoid control, so it's just not even going to work if it gets too hot. Oil temp sensor is a vital input. If the DME detects the oil temperature sensor fault, the ECT will serve as a backup sensor. The intake Vanos solenoid can be swapped with the exhaust Vanos solenoid for diagnostic purpose. The swap them back and forth. Gotta love that from the manufacturer. If the problem moves with the solenoid, then you know the solenoid is at fault, or it could just test it. Be careful not to mix up electrical connectors for the Vanos solenoids, or this can lead to misdiagnosis or other problems. By plugging the intake into the exhaust, that could be a problem, so we don't want to do that. All right, and then we could do signature test, resistance test, or a duty cycle test. So as we said, it controls the duty cycle of this. So this is a duty cycle signal. While snapping the throttle, duty cycle will change as the Vano solenoid on time is varying. Duty cycle will change with increase of engine RPM, load, and or engine temperature. And it should be pretty much nothing when it's at idle because remember, they're off. So we should see off there. And then I should be able to, oops. That's interesting. Huh. Oh, is that off? Oh, my board is off. How'd that happen? My board never shuts off. All right, there we go. There's my duty cycle. That's what I was looking for. All right. So here's a 0% duty cycle. So it's off, 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 off. And then if we wanted to say like a 30% duty cycle, it'd be there. We rev it up a little bit. Maybe my duty cycle goes up like that. Maybe it goes up like that. Maybe it goes down a little bit. Right. So it gives us these, it just gives us a graphical representation of the percentage duty cycle. So it's on 70% of the time now and off less. So it should increase as our RPMs increase, as we saw there. So that's just another example. That's on the variable cam timing system, or variable valve timing, sorry. And then we also have the variable intake, which is Valvetronic, or we have variable intake and Valvetronic. So it has really three systems to change all of the airflow on the system. So the Valvetronic motor, we saw that before. That's got that cam with the eccentric and the worm gear. So the variable valve gear reduces fuel consumption by adjusting the stroke of the intake valve. An electric motor is used to drive a worm gear that moves the eccentric shaft. We saw that earlier. Awesome. Go down, see if there's any tech notes. Most of the mechanical Valvetronic components are precisely matched. Like I said, those little cam arms and the eccentrics, they are precisely matched. If any work to the cylinder head or Valvetronics needs to be done, you must follow manufacturer's repair instructions. Failure to do so may result in engine damage or a very rough idle due to uneven intake valve opening. So that's a problem as well. And then once again, we could do resistance, signature test, or actually a current ramp test on it as well. Since it is an electric motor, we can see the current go through as well. So that's kind of an interesting give us a little pattern like that. Now I can't simulate current in this case, but we should be able to see the current ramp up like that. So it looks like it's got a big kick at the beginning, and then it just makes a nice smooth ramp. We want to see all that. And current flow through each VVT motor should be about the same. If one's higher, one's lower, that's your problem as well. Okay. So with that, that is variable valve timing. Let's talk about what we're going to talk about next week. Next week is another new class that we're doing. So next week is on hybrid vehicle components and testing. So we're going to talk about the basics of hybrid vehicles, how they're set up, the main basic components we're going to talk about, batteries, generators, voltage converters, the electric motors themselves. We'll talk about the different components, how they all work together, and a couple different systems that we've seen, that we have out there in the world. And how are we going to test some of these things? Some of these things you need specialized equipment to test. Other things you can actually test still using your scope because it's not that high of a lot of stuff you'll be doing in the scanner as well. So feel free to join me next week, same time, same place, 6 and 9 Eastern every Tuesday. If you want to watch live on Zoom, go to snapon.com/OT, register yourself a seat. Otherwise, the 6 p.m. Eastern one goes to YouTube at youtube.com/Snap-on Diagnostics. If you are watching on YouTube and you're not subscribed, we definitely appreciate it. It doesn't cost you a thing. And it also lets you know next time we go live or post any new content as well. So make sure you check that subscribe and hit that little bell as well. If you want to see any of the past episodes of this live training, if you're just finding us now, go check this out. ADAS, data bus testing, component testing series we did over the summer. Bunch of different topics, pressure transducer diagnostics. So there's 35 different categories or classes. And then this is class number 36. So if you're interested in any of those, make sure you check it out. Once again, youtube.com/Snap-on Diagnostics. And it is in a playlist for live training. So with that, we will look at questions. But right before I do, let's make sure I also mention my buddy Al. So Al also does diagnostic training for Snap-on. And he does tool-specific training, or we call it platform-specific training. So Monday, it's on Apollo. Wednesday, it's on a Zeus. And Thursday, it's on a Triton. So if you want to get down and dirty in the operation of your scan tool, just come definitely check this out. So first hour on any of these classes is going to be, well, let's make sure your Wi-Fi is on and working, because that's important, because a lot of functions on vehicles nowadays, not just the the ones you might think of. Some functions on a vehicle need Wi-Fi in order to work. So we get that done. We'll make sure you set up your free Snap-on Cloud account, which allows you to manage different settings and also send pre and post scans on the vehicle, things like that to your customers. And then also go through code to completion, walk through a standardized workflow on Fast Track Intelligent Diagnostics and see how does this help me as a technician be a faster diagnosis. So that's the first hour on all the classes, just whatever on the respective tool. Then after a 5-minute break on Wednesday and Thursday, Zeus and Triton, since they have guided component test and scope, Al goes through all the scope and meter functions, a couple of real world examples of things that you can use and take into your shop the next day if you want to. So it's really designed to have your tool with you in front of you and just follow along on the screen and he'll walk you right through it. So Al's a wealth of diagnostics information. He's been with Snap-on Diagnostics since the beginning. So definitely go check him out as well, snapon.com/OT. All right, looks like we got a pretty active crowd here tonight. So let's check our questions. Let's see. Ooh, the sound went out. Did the sound come back? I hope it did. I really hope it. Because that was at 6:07 p.m. I got that. I really hope we've been recording. Let's see, Tom Spina.
It's okay.
Yeah, oh, that's okay. Good, cool. Thank you.
Okay.
Thank you, Al. Always check oil level when dealing with VVT codes. Absolutely. Tom also says he works at a Chrysler dealer, right? So comment on 2.4 liter Chrysler engines. Great seeing your class. All right, thanks. Always glad to have you come in here. And on their Atkins cycle engines as well. That'll be where it opens the valve a little longer. Let's see. Drew says, is there a way to test the cam phasers or is watching the scan data the best way to tell one is bad? I have seen functional tests where you can advance and retard the cam and that they'll be doing a functional test while watching the data so you can see if it moves back and forth. Since there's nothing electrical with the phasers themselves, you wouldn't be able to test them directly. So really it is a scan data and watching how it reacts. You can test the actuators, either that pin actuator or the valve, spool valve. You could electrically test those, of course. But yeah, basically I would say the scan data would be the best one, or if there is a functional test, not every manufacturer has it, but if there is a functional test on it, do that. Let's see. Thank you, Drew. Get asked all the time, be able to test the phasers. So yeah, like I said, if it was, you can do that. All right, let's see. Do we need to check in for this? No, you don't need to check in. Just glad to have you here. I get a report at the end to see who attended. So if you want a certificate or something like that, you just email me and I can get your certificate that you were here. So thanks for checking in, though. Let's see. What kind of magic happens when you clean the sprockets with the scan tool? So it's cleaning the valves. And actually, I think somebody asked me that on YouTube as well. So that functional test on the Jeep. So it's a Chrysler. It goes across many different Chrysler vehicles. As far as I understand it, and actually Tom might be able to chime in on this because he works for Chrysler. But the automated variable valve timing system cleaning, I would suppose it probably makes the oil pressure flow through backwards. So it flows back out and would clear off anything on the inlet screen, would be my guess. Make it flow through the other way. Because the engine does have to be running. So we do have to have oil pressure in order to do it. And it does change how the vehicle runs. So that would be my best guess as to how it does that. I can't actually get in there. Okay, Tom says I'm correct. So that is how it works. So it runs it through backwards, through that spool valve. So instead of going on one side or the other, it just goes backwards, flushes out any contaminants, puts them back in the oil pan for later. We know those 3.6s have a lot of problems with oil contamination as well with that. So there you go. All right, let's go to YouTube. So good to see you guys checking in, Nick and Mr. Gracita. Aficionado, hello, welcome. Thanks for stopping by. Let's see who else we got. Nick loves his Snap-on Zeus. I love my Snap-on Zeus too. Hello, Mohammed. Let's see, 32 Muddin. Yeah, you were the other one who asked that question, so I did see that before. How does using a scanner to clean the VVT items like the preview if the oil is dirty, which causes it? Well, it's going to go back the way it was, basically. So it'll go back into the oil pan, goes back into the system, and then it's just free to clog it again. But I think there is some diagnostic use to that. So if I have a problem on the system and I suspect it's a clog on the valve, if I go and clean it and then it gets better or it gets back to the way it's supposed to be, then I'll know that it was a clog, and then I could address it that way as well. So just kind of thinking about that. That could have some good diagnostic merit. So definitely thank you for that. Let's see. Eve's Automotive, thanks for checking in. Glad to see you. Let's see. Let's see. Michael asks, you may have covered this, and I didn't cover this, so it's good to bring that up. But what kind of effect, if any, could a stretch chain cause on a VVT? So it's going to, the stretch chain will take the whole assembly and it'll move, right? Usually it would go clockwise usually, right? So it's going to advance the whole assembly. So when I go to advance the cam, it's going to over advance, or if I go to retard, it's not going to retard enough if it goes to the advanced side. Or the other way, if it goes the other way, it just depends on which way it's rotating, right? So I'm pretty sure it would all be clockwise if I'm trying to think about this in my head. But yeah, that would definitely be an effect on the VVT because it wouldn't be able to advance or retard the proper way. Yeah, it wouldn't be a permanent fix. Thanks for that question there, 32 months. I was checking in. Raymond, thanks for checking in as well. John, still got the Snap-on Verus. Nothing wrong with that. It's a perfectly good tool. It's got a great scope in it. It's got all sorts of good functions in it. So definitely a good tool there. Glad you have that. Thanks for checking in. Yeah, and Eve says you could sell it as a maintenance, the variable valve timing cleaning. That is a very quick, there'd be a lot of profit margin in that one, I think, for a shop, because that only took a couple minutes, maybe a minute or so to do that. But yeah, it'd be good for diagnostics as well. All right, looks like we got another one on. Let's see. Conrad says, do most engines with VVT have the function to clean the system? Not that I have seen. I have only really seen that on the Chrysler vehicles or FCA, Jeep, Chrysler, Dodge, what have you. That's the only one I've ever seen it on. There could be others. I know there's ways to actuate them a lot, but as far as cleaning specifically, I have not seen that on other vehicles. So be a good thing for manufacturers to add, I would think, if they don't have it. So good question there, Conrad. And Tom, yeah, absolutely. Not a bad idea to change the oil after cleaning the VVT, because once again, we could have it reinfect the problem there. So definitely change that oil. It all boils down to changing your oil and proper maintenance, really, when it comes down to it. So, and then Claude asks on YouTube, is this testing available on all scan tools? Yes. So any of the functional tests, scanner type things that we talk about here is available on any Snap-on scan tool, as long as you have fairly current software on there. The Fast Track Intelligent Diagnostics is only on those specific tools. And then the guided component test is only available on the tools with the scope and meter function. So hopefully I got you there, Claude, on YouTube. All right, good discussion tonight. Lots of folks chiming in. I like it. Let's see. And then Eve's Automotive also says, I think it's on the Ford too, but personally I've not seen it, just heard about it on IATN. So maybe Ford has come around and added that in there as well. So good chat, everybody. Good chat. All right. So with that, I would like to thank you for joining me today. Taking a little bit of time out of your day to come spend with us and get a little bit more schooled up on the inner workings of the variable valve timing and variable valve lift systems on those vehicles nowadays. A lot of good tips and tricks through the crowd there as well. Thank you for that. So with that, hopefully we'll see you next week for hybrid vehicles, and have a good rest of your week whenever it happens to be. And hopefully we'll see you next week, same time, same place. Have a good night. Take care.